In this video, I will be covering object, row, and column level access control in Microsoft Fabric. So if you want to learn more about those topics, stay tuned. Welcome to the video. My name is Alexi, and on this channel I cover Microsoft Data Platform related topics. In this video, we will continue our DP-700 exam prep series. A link to the entire playlist can be found in the description. This is the episode 18 in the DP-700 exam prep series, and in this episode we will cover object, row, and column level access control in Microsoft Fabric. Like in every episode in this series, we will first start with the theory section, followed by demos/tutorials on Fabric, and then we end the episode with few questions related to topics covered in this episode, so that you can test your knowledge. But now, let's get started. Before we get started, let's do a quick recap what we covered in the previous episode. So in the previous episode we covered access control from all the way from the tenant level to the item level. So if you haven't seen that episode, please watch it before watching this one, because otherwise some of the things that I will be talking about in this episode might not make that much sense to you. So the focus of this episode is going to be the most granular level of access that happens inside Microsoft Fabric items, meaning data stores like lakehouses and warehouses. This granular access control means giving access on object, row, and column level. Alright, so now let's talk about this granular access control in more detail. There are three different levels of access that you can control inside Microsoft Fabric item like a lakehouse or a warehouse. These are object level security, column level security, and row level security. Let's start with the object level security, or OLS. This means controlling access to full objects like tables, views, or schemas. If a user doesn't have a permission, they will not even see that the object exists. So it is a great way to completely hide sensitive tables or views from certain users. Then we have column level security, or CLS. This allows you to hide specific columns inside a table. A common example would be hiding a salary or personal ID column while still letting the user see the rest of the table. So the user can query the table, but they will only see the columns they are allowed to see. And finally, row level security, or RLS, lets you filter which rows a user can see. For example, a salesperson might only see rows related to their own sales region. This kind of filtering happens automatically based on who is running the query. So these three types of security can all work together to give you very precise control over your data. And in this episode we are going to cover each one of them step by step and piece by piece. Let's now take a closer look at object level security, or OLS, in the context of Microsoft Fabric Warehouse and Lakehouse's SQL endpoint. So we are going to talk about how to implement OLS using T-SQL statement in those data stores. Object level security means that we are controlling access to entire database objects like tables, views, or even full schemas. If a user is not granted access to a table, they will not even see that it exists. In this example, we have a warehouse with two schemas, marketing and HR. Each schema contains different tables. To give access, we use grant statements. For example, if we want to give access to entire marketing schema, we can write grant select on schema marketing to john@example.com. This gives John access to all current and future tables inside the marketing schema, since we are granting the access on schema level. We can also grant access to individual tables or views using statements like we can see on the screen that would grant access to those three tables in the HR schema. Good thing to know that if we grant access this way, new tables in the HR schema are not given access to, since we are not providing any schema level access. So if new tables are added, we need to give access to them table by table. If we want to block access to a specific object, we can use a deny statement. For example, deny select on marketing budget to john@example.com. Even if John has access to the full marketing schema, this deny statement will override that and block just the budget table. To remove a grant or deny, we can use revoke statement. Revoke does not block access or grant access. It simply removes whatever there was before. For example, revoke select on HR salaries to john@example.com. This clears the permission for salaries table that were previously granted to that. And since the default access has been that there is no access for John, he loses access to that table. Of course, if we would have a person that has access to entire schema or data store, and then we revoke deny access from some table, that user would be then able to see that data after the revoke has been ran. So, to summarize, grant is used to give access, deny is used to block access, revoke is used to remove access rules. You can apply these at schema level or at table level depending how detailed you want your control to be. Also, you can use database roles to grant these accesses as well, meaning that you create specific grants or denies to a role and then you add that role to users you want to apply these object securities to. Now let's move to column level security or CLS. Column level security is similar to object level security, but instead of blocking or allowing access to entire tables, it works at column level. So you can let someone read most of the table, but hide just one or two sensitive columns, like salaries, IDs, or personal information. In this example, we are looking at the HR employees table. The table has 3 columns: name, unit, and salary. In this case, we want to let the user see the name and unit columns, but not the salary. To do that, we use the grant and deny statements. First, we grant access to the columns we want the user to see. Grant select name unit on HR employees to John. This allows John to see only those 2 columns. Then we explicitly block access to the salary column with the deny statement. Deny select salary on HR employees to John. This would make sure that John cannot query the salary column. Of course, in this case, running this deny statement is not mandatory since we only gave this name and unit access to John and he didn't have any access to that table in the first place. And if we want to undo one of these permissions, we can use the revoke statement in a very similar way we used it with OLS. This removes whatever permissions was set before, whether it was grant or deny. Also, these column level accesses can be controlled via role, like object level accesses that we covered previously. Now let's talk about the row level security or RLS. Row level security allows us to control which rows in a table user can see. Instead of showing or hiding entire tables or columns, we can show only the specific rows that the user is allowed to access, based on their identity. In this case, we have 2 tables in sales schema, user region and region sales. User region contains information to which region each user belongs to, and region sales contains sales data per region. Now we would like to use row level security to only show the rows in region sales table that belong to the same region than the person who is querying and using the data. To set this up, we start by creating a new schema called sec. This is just to organize our security-related objects. This step is optional since you could create those security-related objects to any schema you want, but managing them is easier if you have a dedicated schema for them. Then we define a function that contains the row-level security logic. This function takes in a region from the row that is being queried and checks if the current user is allowed to see that row and region. Inside the function, we compare the region of the row with the list of regions assigned to the user. This information comes from a user region mapping table. The username function tells us who is currently running the query. So if the region in the row matches the user's region, the function returns a result, and that row is shown to the user. Next, we create a security policy that uses this function to filter rows in the sales table. Whether someone queries the table, the function automatically checks which rows they are allowed to see. On the right side of the slide, we can see an example. The user John is only allowed to access the North region. So when John runs a select query on the sales table, he only sees the rows for the North region. All the other rows like South are automatically hidden. That is how row-level security works. It gives us row-level control and it runs silently behind the scenes. The user only sees what they are allowed to see and nothing more. And like noted at the bottom, row-level security can be combined with object and column-level securities to create a complete and flexible access control setup. Next, let's go through a few important things to remember when using object, column, and row-level securities in Fabric. First, object, column, and row-level securities all work both in Lakehouse SQL endpoint and Warehouse using T-SQL. So the same techniques we saw earlier apply in the both data stores. That said, there are few practical things to consider when sharing accesses with users. It is usually better and easier to start by giving users only basic access, just enough to open the Lakehouse or Warehouse, and then add more permissions as needed. This is often much easier than giving too much accesses and then trying to take away those later by using deny statements. This approach follows what is called the principle of least privilege. This means that the users should only get the minimum level access they need to do their work and nothing more. So this means that when we are sharing access to Lakehouse and Warehouse, we don't want to check these additional permissions that can be seen here on the screen. Like said, when using these object, row and column level accesses, it is usually the best start without any additional access and then use grant statements and row level security to give access that is needed, rather than giving full access by giving the user read all data using SQL and then removing accesses that they shouldn't have by using deny statements. So always review what you're sharing and make sure access is limited to what is necessary. This will help reduce the risk, keep things simple, and make security easier to manage across your Fabric environment. Until this point, we have been only talking about managing access using T-SQL, meaning inside Warehouse and using Lakehouse's T-SQL endpoint. Now I want to talk about the brand new feature in Fabric called OneLake Security. At the time of recording this video, this feature is currently in preview and not part of the DP-700 scope. However, I'm 100% sure that this feature will be added to the DP-700 scope in the near future, and thus I'm covering it here. Like we already know, when we use Lakehouse, we are actually storing our data to OneLake under the hood. And using Lakehouse, we can store table data and then we can store raw files like CSV and JSON files to OneLake. Then we can use different engines in Fabric to access that data. We have the T-SQL endpoint /engine that we can use to read tables from our Lakehouse. Then we can use access control in that engine to manage access to that table. And that is what we have been covering in this video until now. So those object, row and column level accesses that we covered are happening inside this specific engine. But since SQL endpoint is not the only engine we can use to access the data in our Lakehouse, and we have other engines like Spark, Power BI, etc. that can be also used to access tables and files sitting in our Lakehouse. The problem here is that all of those object, row and column level accesses that we were setting up using the SQL engine are not available when using those other engines. This could lead to a situation where the user is able to access different data depending on the engine that is being used. This is where OneLake Security steps into picture. By using OneLake Security, we can drop down the access management below those engines and have one access control that all of those engines use. So it doesn't matter whether you're accessing the data using T-SQL, Spark, Power BI, Excel, or OneLake File Explorer. The same access control will apply. So OneLake Security allows users to define granular role-based security to data stored in OneLake and enforce that security consistently across all compute engines in Fabric. And this is going to make access control so much more straightforward. OneLake Security uses role-based access control or RBAC, so you can manage access using roles. It works across multiple engines, which means security stays consistent no matter how data is accessed. And it gives you centralized control over who can access what and how. Now keep in mind that when I'm recording this video, OneLake Security is still in preview. And one last note, OneLake Security replaces the older data access roles feature that was released back in April of 2024. If you'd like to learn more about OneLake Security, then I would recommend you to watch the video OneLake Data Security Controls in Microsoft Fabric on Microsoft Mechanics YouTube channel, since in my opinion this video explains it very well what this feature is all about. But now let's go to Fabric and let's do some demos/tutorials there. Before we open Fabric, I would like you to know that I spent a ton of my free time creating these videos for you. And that's why I would like you to hit that like button and subscribe to the channel for more DP-700 and Fabric content. This doesn't cost you anything and I would highly appreciate that. Also, if you'd like to support the channel with a cup of coffee, you can do so by clicking the Buy Me a Coffee link that can be found in the description. But now let's go to Fabric. Now we're in Fabric and I have my DP-700 tutorial workspace open. And I have actually already opened a warehouse in this workspace, because we're going to use warehouse to demonstrate these row, column and object level accesses. But yeah, here I have this setup script that will first create a schema and then create some tables to that schema like employees, sales, and then finance, and also this user regions table, and then also add some rows to those tables. So let's first run this first part of the SQL script so that we get those objects there. So what we're going to do next, I'm going to use my second identity that I created for the previous video to access this warehouse. And now our SQL script has ran and we have those tables here in this warehouse. Let's refresh this and we should have those tables there. There they are. And now I want to only give connect access to my second account to this warehouse so that I will be able to connect to this warehouse, but I won't be able to see any data. And then we are going to use object, column and row level accesses to give some access to that user gradually. But yeah, let's go back to my workspace and then we have to find this warehouse here and then we are going to go to the manage permissions and here I have given that access to my second account, so this Aleksi Partanen 2 account. And what I have done here, I have only clicked this add user button and then I have deselected all of these permissions here and only shared this item with that user so that it will get access to connect to the warehouse but will not able to see any data there. And next I will open up SQL Server Management Studio and we will connect to that warehouse, but we shouldn't see any data there. So we can close this and let's go back to our warehouse. And here we have the settings for the warehouse. And under these settings, we can find this SQL connection string here. We can copy that. And next we're going to open up the SQL Server Management Studio. And here we have the Management Studio and then we're going to copy paste the connection string here. And then we are going to click this options button here. And then we are going to specify that we want to connect to that specific warehouse so that we're able to make the connection. But yeah, now we can connect and we're going to use the MFA authentication and it will connect to that server. And here we can see some databases and we can only see that specific database here because we have only granted access to that one. And under this, we shouldn't see any tables if I'm correct. Yeah, we cannot see any tables or any views because basically now we only have the connect access to this data store. And now we would need to use that more granular access control mechanisms to grant more accesses to this user. So let's do that next. And here I'm giving these select permissions to finance, sales and user regions table. So basically we are giving a select/read access to those tables for that account. And let's run these SQL commands here and then we can see that we have access to those tables using that second account. So let's go back to the Management Studio and now we can refresh the tables and we can see those three tables there. So for now, we can only see these three tables here. We cannot see the employees table and we cannot see other tables in these other schemas. And now we could try to query these tables and see that can we get data out of them. So for example, let's query the finance table and here we can see the data that we have in the finance table. And next, we could use the column level access control and grant some accesses to that employees table. And let's check that in that employees table, we have actually 4 columns. So we have the employee ID, full name, department and salary. And now I'm only granting accesses to those 3 first columns. So I'm actually excluding the salary column so that we're not going to give access to that. And let's run this grant statement and now we have access to that. And now when we refresh the table list here, we should have also that employees table available once this refreshes. And there we have the employees table. Now let's try to do select top 1000 rows from that table and it will give this error message. The select permission was denied on the column salary because we don't have access to that column. So we cannot actually query that. So let's remove that column there and let's try to query that table. And as you can see, we can query the other columns in that table, but we cannot query that salary table because we have not given access to that. Then we can also quickly demonstrate how the revoke will work. So I'm going to revoke access from the department column and we are going to run this and now we shouldn't have access to that department column anymore. So if we run this same code here again, so we don't have access to that department column. But remember that the revoke statement only removes those access controls, so it is not grant or deny. It will return them just back to the default that was there previously. And because the default with this user is that we don't have any access, then the revoke will default it to the scenario that we don't have access to that place. But if we would be playing this game other way around, that we would have access to the entire database and then we would just start to remove accesses by using deny statements, then this situation would go other way around. But yeah, let's move forward with our tutorial. Next, we are going to talk about the row level security. So with row level security, we have to actually create that function first. That will filter that table to which we are then going to apply that row level security to. The first step of creating row level security is to define this function that we are actually going to run row by row when we query the table. And this function will then evaluate whether or not the querying user has access to that specific row. And here we have defined that we're going to pass down this region as parameter for this function. And we are going to use this region to check that whether or not currently the user who is running the query has access to that specific region. And then we are going to basically return true or false if that user can access that row or not. And then this function will only return the rows to the user that he or she is allowed to see. And like said, we could have way more complex logic here in this function to evaluate which row the user is allowed to see, but I only have this very simple example here. And next we have to define this security policy that will then actually use that function that we defined there and apply to the table we want to use that for. And then we have to define that this security policy is actually on. And by running these commands here, we are able to create that function and that security policy so that we actually now have that row level security in place. And when we come back to this management studio here, we can see our previous result that we were able to query 4 rows out of that sales table. But now if we rerun this query, we would only see 2 rows, I assume. Yeah, we can see only 2 rows there, because basically this user that we are using to run these queries is this second account, and we have specified in this user region mapping table that this account has only access to the north region. Because we then have that logic in that function that will then use the data from that table to evaluate the row level security logic. I hope that this demo has now clarified to you how these different object, row and column level securities work here in Fabric. But remember that here we are only using the T-SQL engine to define these, and in the future you probably want to use the one-leg security to define these accesses so that they are applicable in all engines when accessing the data. Next, let's have exam-like questions about the topics that we covered here. You need to allow a user to read data from finance reports table that is in your Fabric warehouse, but they must not see the salary column. User can connect to the warehouse but currently has no access to the finance reports table. What should you do? A. First grant select on finance reports and then revoke select on salary column. B. First grant select on finance reports and then use row level security to filter out salary data. C. Just grant select to the columns user needs on finance reports. D. Just deny select on salary column on finance reports. Now think about the answer for a moment and pause the video. I'll reveal the answer in 3, 2, 1. The correct answer is C, since user didn't have any access to that schema in the first place, so we can just grant access to the columns that the user needs. Option A is incorrect, since we would be granting access to the entire table and then trying to revoke access on salary column to which we don't have specified any access, so there is nothing to revoke here. Option B is incorrect, since we are not looking for row level security here because we need to hide a column, not rows. Option D is incorrect, since user doesn't have any access to the table and thus denying access to salary column doesn't give us the access to the other columns. And that is all that I wanted to cover here today. If you'd like to continue your learning journey towards getting that DP-700 badge, check out the next video in this series. But now I thank you for watching and see you in the next video.